Hello, hello. My name is Peter Tenhula, Senior Fellow at Silicon Flatiron's Spectrum Policy Initiative. Pleased to introduce this first panel, the kickoff panel. Of course, we have to kick off with Spectrum. And we got a superstar panel to do that. I'll introduce the moderator, Julie Kearney, and then she'll introduce the other panelists. I'll note a change in the program. Unfortunately, we had a last-minute change as of Sunday. General Shelton had a death in the family and notified us as soon as he could. And we have a wonderful substitute in his place. Maybe can't fill his shoes, but we'll try with Rich Lee, Silicon Flatiron's fan and supporter. But we appreciate Rich stepping up. Our moderator, and also I would hopefully can pitch it as a panelist too, because her great substantive knowledge in this area is Julie Kearney. Julie is currently a partner and co-chair of the Space Exploration and Innovation Practice at DLA Piper, also a strong Silicon Flatiron supporter. She was the first inaugural chief of the FCC's new Space Bureau, most recently before she left government service to the private sector. I welcome Julie and her panelists and let her kick it off, and we'll be open for a Q&A around 10:35 with a student question. But
fantastic.
Looking forward to hearing their stuff.
Great. Thank you so much, Peter. Thank you to Silicon Flatirons for having me join today. I have always had this coming out to Boulder on my bucket list, and I'm delighted to be here. So also really proud to have DLA Piper as a strong supporter. We have some very illustrious alums on the staff at DLA Piper. So thank you, Silicon Flatirons. Thank you, Commissioner Gomez, for your wise remarks. As Peter noted, I'm Julie Kearney, and I'll give you a quick background about myself. I'm going to have our illustrious panel introduce themselves, but just wanted to set the stage a little bit. I had a wonderful time at the Commission leading the Space Bureau for 2 years, and before that, I worked at Alphabet, which was launching balloons into the stratosphere at a company called Loon to deliver internet to parts of the world that were unserved. And that I call my space balloon lawyer phase. And it really set me up well to understand the needs for spectrum to be wisely allocated, but also that we're ensuring that we're using spectrum in the most efficient way possible. So as we start, I want to give you a few stats from the 2025 Satellite Industry Association Satellite Industry Report. And the massive growth in space services has really fueled demand for scarce spectrum in the US and globally. So for some perspective, at the end of 2024, a total of 11,539 satellites were operating in Earth orbit compared to just 3,371 in 2020. That's a lot. The FCC, for its part, has been doing a lot to alleviate the spectrum crunch and to make more spectrum available for space services. So 2024 in September at the Commission meeting with the support of Commissioner Gomez and fellow commissioners, the FCC took a big step toward the future of space by opening 17 gigahertz for shared use by satellite systems in geostationary and non-geostationary orbits. Yay. November 2024 adopted new rules to support competition and cooperation in spectrum usage by satellite systems for non-geostationary satellite orbit fixed satellite service spectrum sharing. So that's NGSO FSS. So you get a lesson in acronyms today. Also authorized more spectrum for space launches. And just recently, again with Commissioner Gomez's support, unlocking 20,000 megahertz of spectrum. And there is currently a notice and proposed rulemaking out for that. So really exciting times. And with that, we're going to dig a lot deeper into the FCC and the World Radio Communication Conference, but I want to turn it over to the panel and do some self-introductions. We'll start with Tom, we'll go to Kim, and then we'll go to Rich. We're so grateful that you're here today, General Shelton. was unfortunately, as you heard from Peter, unable to join, but because he is very organized, he actually had a person come in and join us. So really excited to have him here today. But I'm going to turn it over to Tom Dombrowsky at T-Mobile.
Hi, good morning, everybody. Happy to be here. I'm Tom Dombrowsky. I know the bio's in there, but you probably are wondering why is there a terrestrial mobile guy at a satellite conference? But in case you guys haven't been reading the news as of yesterday, we at T-Mobile announced the commercial launch of our Starlink partnership for the T-Satellite program. It'll begin July 23rd with SMS and MMS in the Android products. And then by October 1, we'll have skinny data, as we call it. So certain optimized applications will be available from satellite. T-Mobile has always looked at ways to innovate, whether it's in terrestrial use of spectrum or satellite use of spectrum. And really, we always talk about customer love and what can we do to make our customers happy. And we look at the satellite realm as the sort of next environment for us to innovate in and to deliver service to customers where they're not able to get terrestrial service. And our partnership with Starlink is allowing us to move forward with that and use the actual devices that everybody already has. You don't have to replace your device. You don't have to do anything fancy from a customer standpoint. From an engineering standpoint, all we're really doing is adding it to our roaming list. And you're just roaming to a base station that happens to be hundreds of miles up in space instead of a few miles from where you're actually trying to communicate with. So I'm very excited to be here today and look forward to discussing all these issues with everyone here today on the panel.
Great, and Kim.
Okay, good morning, everyone. My name is Kim Baum. I started my career at the FCC as an electronics engineer, and it was a wonderful experience. In just a few small years, I was at World Radio Communications conferences representing the United States, so it was really a wonderful experience that I don't think I would have had elsewhere. Since then, I've held a number of regulatory positions at Motorola, multiple satellite companies, including SES, most recently OneWeb, and now I'm with Astranis. And Astranis, as Anna had mentioned in her keynote, is manufacturing small geostationary satellites in California. And we're taking an innovative approach where we build smaller satellites that are designed to serve like a particular customer's needs. So we're able to do that like much faster than a traditional like large geostationary satellite. So on the order of 18 months instead of 4 years. So while I think you'll hear a lot today about exciting things happening in the non-geostationary space, we would argue that there's a lot of exciting things happening in the geostationary space as well. And I think the focus on LEO and low Earth orbit, is forcing, us in the geostationary orbit to look at new ways of filling, the needs of customers who may want, like a specialized solution instead of, a large global company serving their interest. And we have 5 satellites in orbit today, and we have customers all around the world, APCO in Mexico, Anuvu here in the United States, Orbits in the Philippines, Changhua in Taiwan, and even other satellite operators like Thaicom. So I'm excited to be here and talk more about space.
Thank you. Our favorite subject.
Yes.
Rich.
Thank you. Good sound check. I'm Rich Lee. I'm CEO of a startup that started here at CU called iPosi. We focused on PNT, and one of my heroes in the industry who I'm taking the place of
What
today.
is PNT?
PNT, position, navigation, and time. Thank you.
Thank you.
Acronyms.
Yes.
I've been in the industry not quite as long as Dale Hatfield, about 50 years. I started my career at Motorola, which back then was one of the powerhouses. I've been in the cellular industry a long time. I also migrated into GPS, global positioning systems. And as many of you know, they're in virtually all the 6 billion or whatever it is global cell phones. Why GPS though? What's the role of that? It's not only to position for 911, but it can be used for other advanced applications, which we're working with the DoD on, in shared spectrum. We've got a great resource with the GPS, GNSS signals and upcoming Astranis and other LEO signals to act as a big MRI machine. These emit signals of great interest for sharing spectrum. I won't go into all the dBs and propagation analysis. That's why we have Dale here. But seriously, this is another new application for exploring how to better use our shared spectrum, or our spectrum to share. And that goes for the public operators and the new emerging private 5G operators. Some of you, a few, like Al, I thought I saw in the audience, also know me to be on a board of a stealth LEO company. Believe me, it's not competing with anyone in this audience. It's got a unique mission, but it's to help bring new missions into research, to help commercial entities succeed with their communication or PNT mission, position, navigation, and time. Did I use up my time budget?
No, please. I think we will spell out acronyms just for those of you who may be newer to the space. But I think what we'll do is we'll move into our panel. What you'll notice today, there are a lot of interesting views, and I think as you move, for those of you who are newer to the industry, you'll realize that there are a lot of use cases that fit into many different parts of our world. And we may not always agree with each other, but we always go out for a drink after, right? No matter where we are. And so what I find is interesting, as you mentioned, Tom, there's a terrestrial guy here. 10 years ago, could we have ever envisioned that we'd have this confluence of satellite and terrestrial the way that we're doing it today? So, but now let's move into the question. That was sort of rhetorical. But let's move into some areas where I think it's going to get really interesting. I'm going to throw this out to the panel. What improvements in policies and regulations are required to better manage spectrum conflicts between multiple satellite and ground systems? And I'm going to kick it over to Tom.
Sure, happy to sort of address that as a starting point. So obviously, as I mentioned, we're now looking at having satellites deliver communications directly to cell phones on the ground. And as we talk about these low Earth orbiting satellites, you've gotten much closer to the ground than we ever had with the geostationary orbited satellites. And because of that, more energy comes from those satellites and on the ground has to be managed more consistently to protect both co-channel operations, so the people that are operating on the same frequency as you are, and those that are in the adjacent bands. And that adjacency and co-channel issue becomes a lot more complex when you think about how you mitigate those issues. So for a terrestrial guy like me, we have base stations that maybe have 1 or 2 mile radius of circles around those that you have to sort of protect against and worry about interference. When you're talking about satellites, you're talking about hundreds of miles of coordination that you have to do from one single transmission. So that makes things much more complex and complicated. And I think the big thing to sort of think about in terms of how you manage that is, how do we ensure what's coming from the satellite is actually managing to keep that sort of power flux density, as the engineers would call it, at a manageable level that allows everybody to coexist. And everybody wants to use the spectrum more and more, whether it's satellite or terrestrial. And you have to really look at the engineering piece here, and it's gotten much more complex as we add, as Julie mentioned, we've got 3x in the last 5 years in terms of the number of satellites we're trying to coordinate and figure out how to operate. It has made it much more complex and difficult to sort of manage. I'll turn it to Kim to sort of talk a little bit about how Astranis is doing it, but from sort of the T-Mobile standpoint, we look at it in 2 different ways. So we have the mobile satellite service spectrum that has been traditional satellite spectrum delivery. So think Iridium, Globalstar, others of that nature that are just doing mobile satellite service to devices, versus supplemental communications from space, which Julie's team was nice enough to actually authorize in the last year or so. That's using terrestrial spectrum, but from space in a supplementary basis, so that you have to protect the primary terrestrial users. So as you can imagine, from our perspective, the supplemental communications from space, we want to make sure our terrestrial co-channel operations are fully protected from any supplementary use from space. On the mobile satellite service side, they have dedicated spectrum. So it's really not a co-channel issue necessarily. It's more of an adjacent channel issue. So I'll turn to Kim because they actually build satellites and I don't. Maybe she can talk a little bit about how they're trying to manage that.
And I was wondering too, if you might even want to talk about how the US currently licenses, since you've been on Kim was former FCC, so you were on both sides, as you mentioned, but how we license in the US and to continue with the thread that Tom started.
Okay, thank you, Julie and Tom. So the FCC for satellites, to some extent, has two different licensing regimes. On the GSO side, satellites share the same spectrum by being separated in the geostationary satellite orbit and meeting certain technical rules. So typically, we have geostationary satellites using, say, KU band frequencies like every 2 degrees.
What's KU?
KU band is roughly frequencies from 11 to 14 gigahertz.
There will be a test.
Yes, yes.
Take notes.
And then on the NGSO side, which include systems like what Tom talked about, MSS, the FCC holds processing rounds and seeks interest from everyone that wants to use a given frequency band at the same time. And in some cases, depending on the terminal type, the FCC may license just one system in a given set of frequencies. But if you look at SpaceX, OneWeb, Kuiper, the FCC is licensing multiple systems in the same spectrum and largely leaving it to those systems to figure out, how they share. But since I'm a GSO operator, I'll talk a little bit more about geostationary licensing. So for rights at a given orbit location, the FCC has a first come, first serve process. So the first entity that files, essentially gets the orbit location. And what we see as a relative newcomer to this environment is that you have established geostationary satellite orbit companies that have a lot of satellites, so like old satellites, or they have satellites where they've put on like small payloads that aren't really commercially viable, but they're sufficient for getting a license to use the spectrum. So these companies, by moving an old satellite to a new orbit location or putting additional like mini payloads on a satellite, are able to get a license to use the spectrum for 15 years. And also they're able to avoid some of the FCC's requirements for putting up a surety bond because they already have the satellite in space. You don't have to put up a bond to maintain those rights. So that creates difficulties for newcomers getting access to spectrum. And so we would like to see the commission kind of look at what's in the public interest. Is it continuing to license, payloads that can't provide commercial services, or these older satellites that aren't really capable of providing commercial service, or if it would be better to open up to new companies to provide service. So that's one issue I wanted to highlight today.
Question, how do you think improvements in the process could help companies? What types of improvements do you think would be helpful? Well, more spectrum.
Yeah, well, I'll address that first.
And I don't want to leave Rich out of it. But
Yeah,
we'll get to Rich. Yeah.
Let Rich get there. So on the geostationary side, I mean, as Kim said, you get sort of an orbital slot and you get a certain set of frequencies that are there. If you look at that, they typically have sort of a degree separation, so 3 or 6 degree separation between these geostationary orbital slots. If you could shrink that with better antennas and better capabilities, maybe that's a way you can get better reuse of the spectrum. It's what we have to do in the terrestrial environment all the time. However, again, going back to we're coming from space, so it makes it a lot more complex than it is to manage on the terrestrial side. On the non-geostationary orbit side, I think from my perspective, as you look at where we're headed and where things are going, parties continue to file again and again in these processing rounds and sort of force a process there, regardless of whether somebody before was using the spectrum or whether that party would maybe have a desire to move to a non-geostationary orbit operation. So in a lot of cases, folks that are targeting the new NGSO new non-geostationary orbit, low Earth orbiting satellite systems are looking at geostationary orbital systems and seeing, hey, can I share with those guys, or can I piggyback on top of them, or can I get some of the spectrum they're using? So if we look at that more broadly, I think it would be helpful to drive more use of the spectrum, of the existing spectrum assets. So again, as everybody knows, things are getting more and more crowded there, whether it's space or spectrum. And any way we can get more efficiency and more effective use of things has got to be something we should focus on.
Great. Thanks, Tom. Rich, we're going to kick it over to you and hear your deep thoughts.
Well, I'm going to use a prerogative here. I'm going to ask the panel here. How many SATCOM operators do we need? Is that talked about at all? How many folks need to be up there? And there's different plays here. There's a wholesale play, there's backhaul, there's various kinds of retail, and Tom's approach here of having with TMO, very interesting complement for not only coverage, but perhaps emergency and other new applications, IoT applications. But how many different operators do we need? I know from kind of my scan of the PNT with General Shelton and others, there are about 11 internationally with the US and focused on PNT, possibly doing combat. How many folks, how many companies need to be engaged in this and remain competitive?
I work for a law firm, so lots.
More
All of
clients.
them.
And my perspective on that is let competition sort of decide how many there should be. You should let, we always say 1,000 flowers bloom, and then see which one ends up there. If you need 10, you have 10. If you need 5, you get 5. It usually comes to equilibrium at some point. So I think anytime you try and guess what the right number is, you're doomed to failure, at least from my perspective.
And I think, though, as you see a shift towards NGSO operators, there's a lot of consolidation in the satellite industry going on to try to compete, I think. But I think because of that consolidation, it's critical to be looking at ways of ensuring the spectrum is being used efficiently, being sure there are opportunities for newcomers to acquire spectrum.
Right. And I think Commissioner Gomez talked about her recent trip to California, and I've done a lot of those trips as well, and it's incredible to see the innovations that are coming, and you have to wonder, what is the limiting factor, right? Is it spectrum? Is it access to capital? What is it? I don't think we're there yet. I think we're still in that phase where people are continuing to innovate, and I'll go back to Tom, where competition is really going to sort out where we ultimately end up. But it's an exciting place to be. Did you have anything else you wanted to add on the regulatory?
I'm trying to draw from the rest of the panel's
Yeah.
expertise.
Okay, great. Well, we'll continue to draw from the panel. Let's go to the World Radio Communication Conference 27. And the question for the panel is, how can ex-ante spectrum allocation disputes be peacefully resolved ahead of the World Radio Communication Conference?
As the non-lawyer, can you explain what ex-ante ever means? It's Latin, I think, or something.
Ex-ante is beforehand. What can we solve before regulations are established? And I'll do a little bit of discussion here really quickly of the World Radio Communication Conference. This is the work, the International Telecommunication Union in Geneva is the international body where pretty much every country in the world is a member. And they have a World Radio Communication Conference, a global intergovernmental treaty conference every 4 years. And right now we're trying to figure out where it is going to be in 2027. The US has just thrown its hat into the ring. It might be Geneva. It's supposed to be, was it originally supposed to be Shanghai? And potentially, I think Africa was in the running as well. So this almost seems like the Olympics, but apparently the US threw its hat into the ring today. The most recent WRC happened in Dubai in December of 2023, and delegates updated the world's radio regulations. Kim, you were there. Many of the people in this room were there. The radio regulations, that's the treaty that governs the allocation and use of radio frequency spectrum and satellite orbital locations. And it was 5 weeks long and people are still recovering. The work has actually started for 2027. But back to WRC, it's how we globalize the scarce spectrum resources to support the communications that we use in everyday life. So 80%, as Commissioner Gomez mentioned, 80% of the items are space related. So we are informally calling it the Space WRC. It is unprecedented to have so many space related items. Kim might give us a little bit of talk about how are some of the things that are coming up in the upcoming World Radio Communication Conference, how might we peacefully resolve some of those things ahead of time? But feel free to meander.
Well, thank you, Julie. I mean, it's really an interesting agenda. Each conference has a set list of agenda items that they're supposed to work on. And as has been said, there's a huge number of space agenda items for this WRC. And if you look at those, there's an interesting kind of tension. There's a number of agenda items that are intended to facilitate or enable these new type of NGSO systems that we're seeing coming online. But there's also like a reaction to those systems, to those global systems that you see in other agenda items. So, you know, I think other countries are concerned about, you know, these large global systems that are, you know, being built essentially by the United States. And so there are agenda items looking at, you know, equitable access, looking at potential planning or other means to ensure access by other countries.
Can you talk a little more about the equitable access thing? Because I think that's really interesting. And then we'll put a pin in.
Okay, so for a long time in the ITU and I guess in the world at large, there's been a real tension between kind of those who have space activities or satellites already and those who don't.
So a lot of developing world versus developed.
Yes, yes. And
Tension.
to deal with that and to enable, you know, countries like the United States to continue to build and operate satellites, over the years, the ITU has come up with different approaches. But the first approach to address kind of equitable access was developing plans in the 70s and the 1970s and 1980s that would set aside frequency at
You said disco. That's a whole
yes, yes.
satellite act.
So the plan would, you know, set aside a given orbit location and frequencies for Rwanda. And that plan assignment would be there forever for them for when they chose to use it. So that was one mechanism that was used. But, you know, then you have to enable like means for real systems to build around those plan assignments and actually be implemented. And systems that operate in the plan bands for a long time are like DirecTV and Dish, like in the BSS plan bands. So, you know, some countries like seeing SpaceX and Kuiper and these big global systems are looking for additional plans, perhaps in QV band frequencies, like from 37 to about 51 gigahertz. You know, so you see like, you know, a push towards global systems and making them more possible, and then, you know, kind of pulling back, and each country wants to still have access to space and spectrum.
And we want them to, but it is that tension, right? What can we settle? Where do we go now between now and 2027? And will we ever resolve these very difficult questions? I think, Kim, maybe if there are any other items that are happening at the WRC you think that would be interesting to talk about, like these EPFD limits or direct-to-device issues or lunar, are there some things maybe we want to talk to the crowd about?
So
And weigh in, please, others, as you feel.
EPFD, equivalent power flux density limits. It's a sharing regime that was developed in the late 90s and finalized at WARC 2000 for non-geostationary systems to protect geostationary systems and enable these NGSO systems to use the same frequency bands bands without having to go around the world and coordinate with every single geostationary satellite system. So it was really intended to enable NGSO systems. But those systems that were envisioned at the time weren't implemented. I don't know if folks remember Skybridge or Teledesic or, those systems. And instead, we're here 20-some years later, and we have very different looking systems, with many, thousands of satellites instead of hundreds. And so there was a big push by the United States to have an agenda item for WARC 27 to look at revising those EPFD limits because they were becoming very constraining on the NGSO systems. But because of some of those tensions that I talked about, the US couldn't reach an agreement with all these other countries to have an agenda item. So instead, there's text that technical studies should be done, and those should be reported back to the WRC with no regulatory consequences. So here in the US, given this big push, the FCC has issued a notice of proposed rulemaking or an NPRM looking at changing those EPFD limits, at least on United States territory to give more flexibility for NGSO systems while still protecting GSOs. So I think that's one way, Julie, where the US is looking at kind of paving the way, or starting the discussions here, and while continuing to work on those technical studies on an international basis.
Yeah, and I think, Tom, did you have something? Thank you, Kim.
I'll talk to direct device, but
Yes.
finish this topic first.
Yeah, I think that is definitely something with the EPFD limits where we have two different groups in the US who, for and against, and how it will inform how what happens in the US regulatory process will inform what happens at the World Radio Communication Conference in whatever country it happens to be in 2027.
Yeah, and I'll just to finish off on that. I mean, I think the other interesting thing is it's not just NGSO, non-geostationary to geostationary. It's also other NGSOs have different perspectives depending on how their satellites are configured and all that. So that makes this problem that much more complex, and it's good that we're spending the time to sort of dig into this well in advance of the World Radio Conference. But if I can, I'll
Yes,
shift gears to
please.
direct
Yes.
device. So as Kim said, they have agenda items here, some of which are satellite related. The one that's of interest to T-Mobile is agenda item 1.13. What that's looking at is the direct device issue and how do they do that. And they're looking at the 698 to 2700 megahertz band and suggesting how do we take that terrestrial spectrum and have satellite use of that band while still protecting the terrestrial use. From a terrestrial mobile operator's perspective, we believe that band is a terrestrial mobile band and it should be primary for terrestrial mobile services. Other countries and other parties have slightly different opinions about that. Maybe they want to be primary in their particular country for that particular spectrum band or not. But from a mobile operator standpoint, we think it's very important that any terrestrial, and it's International Mobile Telephone Specification, IMT is the other acronym they use there, any IMT spectrum is still primary terrestrial. And if the terrestrial operator wants to use it to help supplement it with satellite, that should be secondary to the terrestrial operation. So there's a lot of debate and discussion about how do you make that happen? How do you protect the terrestrial operations? How do you implement all these satellite systems so you don't cause problems to the co-channel terrestrial operators as well as any adjacent operators? So as you remember my earlier comments, that gets very complex when you're talking about operating from space. So it'll be a pretty heavily argued argument there, I think. I don't know what you think, Kim, but I think that one's going to be a lot of fireworks.
Yes, definitely. And, I think, again, because the US is kind of out ahead on implementing this, that causes some pushback, I think, from other countries. And it's also an interesting discussion about, operations under radio regulation 4.4, like on a,
Right.
where you don't have an allocation, there's this one provision in the radio regulations that you operate under. So those discussions are interrelated as well and quite contentious.
Well, and it's really interesting as well. So the US, we have regulations, and the first license was issued to operate for T-Mobile and SpaceX, the Starlink service. where the US came out with rules, has issued licenses. Canada is in the process. They've now issued their framework. They haven't issued any licenses yet, but you have a lot of countries who are looking, what has worked? What have you learned operating within the confines of the 4.4? But this is, again, that's like a chicken and an egg. Will we have more sort of global uptake? How will that impact WRC discussion?
Yeah, I'm not sure how it'll impact WRC, but I think in our case, we actually took terrestrial spectrum, 10 megahertz
Yeah.
of terrestrial spectrum, and dedicated a lot of it towards the supplementary communications from space. The reason why a lot of other parties in other countries haven't gotten there yet is no one wants to take
Give up.
very valuable terrestrial spectrum and migrate it over to satellite use. We saw a need and we were actually stepping up, and we're still using it for terrestrial, but also using it for satellite. So I think the number one problem, as always, is how do we get more spectrum and how do we use it more efficiently? Secondarily, we have the mobile satellite service that's out there and been used sort of as a standalone service. A lot of those folks would love to integrate that into the same way that we've done it, but the problem being we use terrestrial spectrum, so it's already in the mobile device. The MSS spectrum, the mobile satellite service spectrum, with the exception of all the work Apple and Globalstar have done, is not resident in your normal mobile device. So that's another sort of barrier to entry that we have to get over as well, is how do you seed those devices? How do you make sure they operate peacefully with the rest of your terrestrial operations as well?
Yeah. And, oh, yes, Rich, please.
I'm going to draw on the expertise again, but Tom and Kim, is there any move afoot over the next few years to increasingly modify the user device to make it more satellite compatible, close the link, as it's called, for higher bandwidth than, say, just text?
I think most of the work is on the satellite side more than the mobile side. So obviously we've gone from geostationary, which is tens of thousands of miles up in space, down to hundreds of miles in space. So that's helped close the link dramatically. That's what's made this service possible, is we've closed it that way. And I think they're looking, I mean, Jennifer Manor will be on a later panel. AST's got a much higher power antenna that they want to use for their service. So a lot of the sort of innovation is on the satellite side, more on the mobile side. But yes, I will say, without giving away company secrets, we're certainly looking at how we can optimize the customer experience from the mobile back up to the satellite as well. But I wouldn't say there's going to be fundamental changes to the mobile device to sort of close that link.
Well, and I think to Tom's point too, you want to have as much penetration in the market with people who have the devices in hand already. So to have that ubiquity as you're continuing to deploy the service.
Right. I mean, it's just like any other sort of technology transition. You want to have the devices seeded to people before you turn on the service, and they say, hey, it doesn't operate like you said it was going to. And it's like, well, you have an old device. You need the new device. And customers don't really like buying new devices. I don't know why. I highly recommend you buy new devices. It would be great for our company.
And then I had another couple issues to add. Did you have anything else you wanted to add, Rich?
That's fine.
Lunar and space sustainability. I don't know if we want to talk about that here, if we're comfortable going into that, but there are, of course, lunar items with the prevalence of lunar communications. I know we have people here. I see Jennifer Warren, and others who are working on services that are going to be lunar-based. Very exciting. Did we have anything we wanted to talk about there, or space sustainability? We all want to protect space. Yes.
So on lunar, certainly there's an agenda item. A number of frequency bands have been identified to look at studies of, how we can enable, use of these bands on the lunar surface and for communications between the surface and, the orbits around the moon. I think, one of the key questions, and of course Jennifer is much more of an expert on this than I, but is, looking at this from a definitional perspective within the radio regulations, now you would just have to call any operation on the moon like a space station, but, to truly categorize it separately, I think there needs to be some more definition of terms.
Yeah.
But I think it's certainly exciting to see the spectrum world keeping pace with, this exciting time of getting back to
Yeah.
the moon.
And I think the other thing is, just like any other spectrum battle, when you start to do new services, you typically look at spectrum that's being used for other services. So making sure that as you move towards lunar, that you're protecting existing incumbents as well is another tricky part of that effort as well.
Right. Yeah, absolutely. Okay, now we're going to move on to the next question. What is the role and reliability of ex post, e.g. monitoring and enforcement to ensure interference-free coexistence among in-band and out-of-band users in space and on the ground? I know Tom and Rich have lots to say
I'll let
here.
Rich go first.
Is it okay to say deportation? No, but that is going to be interesting, but smart folks like Tom and Kim are going to, I'm sure, design more software-defined radio systems and intelligent beamforming. And this medium is really making interference resolution, as densities grow, of course, easier to resolve, I think. Would you agree? Put it back to you.
Yeah, I mean, I'll talk a little bit about interference resolution. I mean, monitoring and enforcement, playing off of Commissioner Gomez's comments about, the cutbacks in the government. Realistically, we would not expect the government to continue to grow. And in that case, how does the government monitor and enforce? And I think what we've seen in the past 30 to 40 years at the FCC is a recognition that there is an ability to privatize monitoring and enforcement. They have frequency advisory groups that do actual frequency coordination ahead of time. They've privatized the certification of equipment. So most equipment is done by a third party, not by the FCC. I think the similar things could be done on the monitoring enforcement side on the satellite realm, as well as on the mobile realm. And I think that's something we need to be really looking at very closely. Number one. Number two, I will say, and I'm former FCC, so I'll never say anything bad about the FCC, but what you'll see with FCC is they're extremely conservative when they do a first decision. And to Rich's point, as we're getting smarter and smarter equipment, the need for really conservative first assumptions doesn't make any sense to me anymore. I think you need to sort of let the folks get out there and innovate and cause problems and resolve it on their own. I think I was at the FCC 30 years ago and we got yelled at because we were allowing this personal communication service to happen and we weren't really regulating it like we did the cellular service, and everybody told us it would be a disaster. I'd question, did anybody not have a smartphone right now? Did it turn out okay? I think it turned out okay. I think we managed it.
Turned out too well.
Yeah, hey.
No, it never turns out.
Never too well, never too well. So I think there needs to be a recognition that, the government certainly has a role here, but given the diminished resources they have there and the speed at which the industry is moving, the need for some privatization and sort of less conservative first assumptions when they actually authorize services. And I'll leave a last point on that. Generally, they're so conservative, you don't see a lot of interference complaints after an FCC decision. And there's a reason for that. They've belt and suspended it so tightly. The idea that there would be an interference problem is sort of beyond the pale from an engineering standpoint. And I would argue, given the sort of scarcity of spectrum, that you need to sort of push the envelope a little bit on that in order to actually get more use out of the spectrum.
I want to say it's the incredible talent working on the issues at the FCC.
Absolutely.
And our stakeholders, or their stakeholders. Kim, did you have something you wanted to add?
Well, I guess if you look back at the EPFD question that we had addressed earlier, the FCC, had turned from looking at the EPFD analysis itself to relying on the ITU's finding that the EPFD limits were met. So I think as we're looking into, what do we replace the EPFD limits with? There's one question is, what criteria should that be? And I think some of the criteria is fairly extreme, noting that Tom mentioned belt and suspenders, but looking at changes in absolute availability, like on the order of 3% could have a significant impact to other systems. But there's also a question is who's gonna determine if those things are met. You know, is it the FCC? Is it going to be, you know, individual systems? But there should be a means for, you know, others to comment on, you know, analysis to help ensure compliance.
Yeah, no, I agree with that. I think the FCC has a very strong auditor role of these things, and it's what they do on the equipment authorization process, is they set out a guideline. If it's met, the third party can go forward. If they have questions, they go immediately to the FCC and say, I have questions. I don't know how to do this. This is something new. This is something novel. I'm not sure how I should handle it. And the FCC is the sort of final arbiter of any sort of disputes or questions. And I think it could work in other contexts as well. Go ahead, Rich.
Well, one thing I wanted to add, and I was sensitized to this, Al, visiting his lab earlier last week, I guess it was, Al from CU is doing tremendous research with his students in environmental systems and sciences. And one of the questions earlier to Commissioner Gomez touched on this. Could we see formalizing in the regulatory process as we're growing these ecosystems, formalize the role of environmental science, who doesn't have the commercial power, or if I'm using that term correctly, but the readiness to assert their needs in a way that, you know, rebalances this. We're also hearing about this around the world. Africa is going to have unique environmental science needs, the polar caps, et cetera, et cetera. It seems like we need to do something about that.
Mm-hmm. That's great. So let's move on to our next question, shall we? Okay. We may have answered this a bit, but we may have a little more to squeeze out of this this fruit. How are new and innovative direct-to-device services and position navigation and timing services being accommodated under existing and modified spectrum management approaches?
Yeah, I feel like I've addressed this a couple times, but I'm more than happy to talk about it again. So we have the supplemental communications from space ruling in the last year, which we're launching our service with, where you're repurposing terrestrial spectrum on a secondary basis, doing satellite communications. We also have the mobile satellite service that has dedicated spectrum that's just for satellite use. And I think a lot of those were started out with geostationary orbit satellites, or maybe, as they called them, big LEOs, which I'd never understood what was big about them. Maybe it was big satellites, but nowhere near the number of satellites that we're seeing now for the low Earth orbiting satellites. So I think we're seeing sort of a growth in both areas. I think what's still left to be seen is there a way to merge these so that it works well for both, or is it going to always sort of stay bifurcated? And is that the best way to do that? And then the final piece is something I already mentioned before too, which is how do you make sure it's in the device? So mobile satellite service spectrum is not in your device now, with the exception of the Globalstar Apple spectrum. So how do you get that into the device and do it in a cost-effective way and seed the environment with that kind of capability quickly and seamlessly, so the customer doesn't know what's going on?
Okay. Any other additions? I think we're nearing in on our Q&A, unless we have any more inputs from our panel. Okay, I think we have 16 minutes left. We don't have to use every minute. We can get you to coffee, but let's open the floor to a student. Yes, and if you could tell us who you are, that would be great for the panel. Did you have a question? Not a student. Okay. Do we have any student questions? Okay, you are up.
Hi, yeah, thank you very much for this panel. It was very informative. Quick question regarding the supplemental coverage from space that operates in the US under Regulation 4.4. I was wondering if we've had already issues of interference with neighboring countries, and if we had not, what is the plan for conflict resolution if it were to happen?
So I'm currently not aware of any, I'll let Tom know, but I'm not
Yeah,
aware.
so
Yeah. And where are you from, may we ask?
Oh, sorry, Caltech,
Great.
California
Oh,
Institute of
great,
Technology.
wonderful. Yay,
I'm
California.
another undercover astrophysicist in
Oh,
Beverly.
great.
no,
Don't
I
be
mean,
undercover.
I think we have the benefit of in the US of having a Mexico and Canada border that we have to worry about. We don't have 30 or 40 borders to sort of manage, especially with satellite where it could get that much more complex. We're using our PCSG block, which is 1910 to 1915 megahertz paired with 1990 to 1995 megahertz. Mexico doesn't have a licensee there, so there's no one to interfere with. In Canada, there's licensees, but we have sort of a back off from the Canadian border. We've been working to negotiate both areas around the border for both Canada and Mexico, but no interference issues have arisen, and obviously couldn't with Mexico because there's not an operator that we could actually be interfering with.
Any other questions from the floor? Yes, we have another question.
This will be an odd question, and it will be crucial, I think. I'm taking off a little bit. I'm a humanities visitor from afar. The astrophysicists are sensitive. It's nothing to what the humanities are. But I think we're really useful. And where I am thinking, so important, translators and interpreters. I'm responding a little bit to the acronym issue, but also to all the international negotiations. So if you have this very complicated technical field, and then you have a whole bunch of different countries speaking different languages, I'm just wondering, would some of the tensions, conflicts, and so on turn out to be matters of misunderstanding that having a whole team of maybe humanities people who are always looking for employment, having them circulate at the world conferences and just as really carriers of messages, just noticing where mishaps of understanding are happening, that maybe would that reduce the conflicts and the tension significantly if those translators and interpreters were deployed?
Yeah, I'll go first and I'll defer to the experts on this. But from my perspective, the arguments are not because they don't understand each other. The arguments are because they're competitors, whether it's country competitors or other things. So, and a lot of it's political, even more than just engineering. So I'm not sure the humanities would change it necessarily. I think maybe it'll make it even more obvious what we're arguing about, but I'll defer to the experts.
So certainly, the ITU has very expert staff like interpreters, so I think when you're at like a formal ITU meeting, the interpretation services are very reliable. But when we do go to meetings here in the Americas, like CTEL, part of the Organization of American States, things are like lost in translation on the floor. And so I think in those cases, more often side conversations happen to discuss issues, but then often the discussions are in English, because of the Americans. But, some misunderstandings do happen, I think.
I think in any international setting, you have to go in with a bit of an open mind and patience and humanity. So music major here, now lawyer, part-time engineer under supervision from engineers. But I do feel like we have a lot of very experienced people. And ultimately, I think Tom said there's a competition among private sector and countries, and everyone needs to be as transparent as possible. But I think ultimately the translators do an amazing job. They translate into 6 different six different languages. And I think they do amazingly well. Thank you. That's a great question. Oh, hey, whoa.
Just happened.
Okay. Where do we start? Is there a student?
No student.
Okay, no students. Following the wiser rule. I saw you first. Yes. If you could let us know who you are. Yes. Gentleman with the hands up.
Thank you. My name is Al Gashevsky, and I work at CU here.
Wonderful.
And I have a comment that sort of builds on Commissioner Gomez's discussions earlier regarding agency, collaboration, cooperation, et cetera. And it has to do with the proposed rulemaking on spectrum abundance that's now out for comments. One of the bands that was proposed for satellite uplink directly uses a current NOAA sounding band that's actually quite critical for weather forecasting. This is in the neighborhood of 50 gigahertz. I won't recite the precise frequencies, but you can look that up.
51.4 to 52.4.
Yes, it falls directly into a band that's not only used by NOAA nationally, but by many other countries internationally for weather forecasting. And as we now know, as a result of a number of studies over the years by ECMWF that have been corroborated by our own NCEP, that these passive microwave bands provide something like 50% of the information content into our weather forecasts. And so with regard to interagency collaboration, I'm just wondering where it was that that specific channel was somehow put up for consideration here.
That sounds like a great comment for you to submit in the notice of proposed rulemaking, but there is, NTIA is will work with all, right, with NASA and NSF and others, including NOAA, if they decide to submit their own comments.
Well, and I'll just note that it's not a decision.
Right.
It's a proposal, and this is how the process works. If you never went after a ban that there's an incumbent, we would never, ever have another FCC rulemaking. So they kick off these things. It goes through an NTIA process. NOAA is participatory in any NTIA process. When they get to an actual decision, your comment may be most appropriate, but I think at the bottom line is they haven't actually made a decision on the ban yet. And it's one that's been kicking around at least 15 years. I mean, we had pushed at one point for terrestrial mobile use of the band too. So it's not a new idea. It's just something they've now teed up again. And it's part of the sort of FCC process is they're going to ask questions and they're going to force parties to provide technical detail as to what's going on in the band, why it's critical, how it can be protected. And the answer cannot usually be because just no. It can't just be no. It has to be here's why you need to protect me, here's how you protect me, and provide some sort of technical detail as to why you need to be protected and how. And the FCC does, as I said earlier, a very conservative job of protecting incumbents generally. So I think through that process, they'll get to the right answer. They generally do. And if they don't, there's still another appeal process after that. So these processes go on and on and on, and there's always the opportunity for parties to present their opinions.
And can I note too, and thank you for the question, by the way, it's a great question. I'm quoting from the NPRM. This is not an opinion of me or any client. It says these underused bands located in spectrum neighborhoods, ideal for satellite broadband, are prime candidates for modernization. And that's directly from the NPRM. So I think it'll be an interesting comment period.
I will just point out that they are used though, so I'm not sure about that
Right.
word underused.
Not my word. I wasn't there.
And I would add.
Thank you.
Thank
One
you.
of the recent WRCs has dealt with this frequency band, so looked at sharing with other services. And, so maybe some of those provisions can be relied upon. But I think this band has been looked at for satellite uplinks internationally already.
Yeah, I think it'll be interesting. We'll be looking forward to the comments. Thank you. Any other? Oh, yes. Where?
You're in charge.
You, please. And if people could raise their hands, so we had two other questions? Okay.
Three, four,
Oh, three,
five.
oh my goodness, okay.
Keep growing.
My name's Dan Baker at CU. My understanding is that SpaceX has authorization for 42,000 more small satellites at low Earth orbit, just for the Starlink kind of communication. What do market analyses suggest is going to be the number of satellites needed to service when everybody on Earth with a cell phone wants to use low Earth comms as well? And the panel.
I see SpaceX.
I see
in the
David
room.
Coleman up there, and he's going to talk later. You can ask him
David
that
Coleman
question.
will-
Maybe he has it, because this is fun to throw it to David.
Okay, hold that thought. We have SpaceX in the house.
I think it's very relevant.
Yeah. I don't think any of us have anything we want to talk about. Okay. Thank you. We'll take. Okay, I see a hand here. 2 or 3 questions at once, put them up on the table. Okay, so we'll ask the questions of the 3 of you, and then we will
Whip through 'em.
whip through them. Thank you,
Hey,
Brad.
Puyan Amushay from NTIA. I have a question about spectrum sharing. In terrestrial world, for almost 20 years, we have been talking about dynamic spectrum sharing. As a matter of fact, me and Peter worked in shared spectrum company 20 years ago. We talked about dynamic spectrum access for
Right.
so long. I was wondering, and now people are talking about AI, ML for spectrum management, but all of this is happening in the terrestrial world. I was wondering if there is any efforts of doing spectrum sharing between terrestrial and satellite networks, doing kind of DSS type of thing, dynamic spectrum access or dynamic spectrum sharing. Thank you.
Okay, dynamic spectrum sharing. Okay, well, we'll knock it out.
Well, I'll take a crack at it. So I think you're probably familiar with dynamic spectrum sharing and the initiatives there. And I personally believe that the satellite world could come into that in addition to terrestrial and in addition to deep incumbent sharing, such as the DoD and NTIA coordinating it. I think there's a lot of spectrum that can be exploited there.
In future standards where 6G is certainly looking at how do we integrate satellite directly into the standard. And if we have the exact same standards mandated for both satellite and terrestrial use of the same spectrum, sharing becomes that much more easy.
Great, okay, I saw a couple other hands. Yes, please. 1 minute.
1 minute, Kelsey Johnson, University of Virginia. So again, passive user here. Very interested in maintaining passive use and access to the universe. I think we all love the universe, yes, and like nods of heads on that. Can you say more or really anything about what active users are doing to maximize the efficiency of the frequencies that you do have access to, right? Because I hear over and over again, we need more frequency, we need more frequency, we need more frequency. Message received loud and clear, knowing that every time you get that frequency, it takes away a window to the universe. So what are we doing to make sure we're using that frequency as effectively and efficiently as possible?
Yeah, so every generation of the mobile standard has gone from 3 to 5x more efficient use of the spectrum, number one. Number two, we do a lot of reuse of the spectrum. So back in the day when I started doing this 40 years ago, we have 10, 15 mile radius boomer satellite base stations that were covering the populace. We're now down to hundreds of feet, if not indoor, distributed antenna systems indoor. So what we were trying to do is reuse those same spectrum bands over and over again, more and more tightly. When I first started doing this, we would split it up by frequency or by time, then we added in codes. Now we're actually getting it down to sort of what we call a physical resource block, and we're prioritizing each of those little blocks of spectrum to reuse it again and again. The last thing as a mobile company wants to do is to have to go to another auction and buy more spectrum if they can avoid it, if there's a better way to do it. So we're constantly driving the standards, driving the vendors to actually use the spectrum more efficiently, and that's what I can say about the terrestrial at least.
And then from the satellite perspective, as I had mentioned, I think we need to take a close look at, how some orbit locations are being used. If they're not being used, then they should be opened up for someone who will actually use them in existing frequency bands instead of having to look for higher or different bands. So, I think we are looking at ways to be sure the spectrum really is used before we look for more.
I'll make a plug for the Wind Forum. They've just opened standards development and what's called highly dynamic shared spectrum. Michael and others participate in that. And I think that's going to be, to answer your question, how we are going to concentrate more use and reduce the pressure in just taking up more megahertz or gigahertz up the band.
Yeah. I think, anyone? I think we're up, but I want to ask, I see Michael Calabrese. Can we have one more question? If it's a really quick one, Brad? No, I was about to say, Mother, may we? The gentleman in the white shirt.
Raise your hand, Michael.
Raise your hand, Michael.
Yeah, I hope it'll be quick because I'm trying to
Make it quick.
build
Counting.
on what you just
Okay.
said is that so IMT, the terrestrial mobile has incentives, has faster changeover in technology, going up the Gs. Kim mentioned that some of the old satellites in orbit may not be using the spectrum capacity, and then technology is developing. So with spot beams and software-defined upgrades and so on, we can use satellite spectrum much more efficiently. So the question is, how should the FCC think about either sunsetting protections, for example, or requiring as part of the original authorization or modification some level of having the latest coexistence technology? Should they even be thinking about that, or should they just say, no, it's anything goes?
Yeah, I mean, I'll go first. I mean, I totally agree with that hypothesis there. I mean, I think there needs to be, some impetus to push folks to continue to innovate. And especially in spectrum bands that are not subject to auctions for their licenses, because there's not that sort of financial imperative to recoup the money that you spent to buy the license. So any way that they can force that would be a good thing from my perspective, and finding ways to sort of relook at satellite licensing writ large. I think to Kim's point, you've got satellite slots that are camped on by people or using systems that don't really have deliverable payloads. I mean, that doesn't seem like the right answer. I'm not sure, I don't have the answer to the question as to how you get there, but I'm more than happy to have a discussion about it. I think it's something that's very important and vital to have. And I'll just add the last thing is, from my perspective as a guy who does terrestrial more than satellite, it's utterly frustrating that you cannot figure out how satellites operate by reading the FCC rules. You cannot. You have to go and read the 17 orders for every particular satellite system, and I think that would be another way to be nice to sort of
Transparency
revisit it.
Initiative.
Yes,
FCC Transparency
yes.
Initiative. Go check out the website. But I think there is a balance between having rules reflect the innovation that has happened, but also respecting the innovation that has been built to the rules. So it is a balance, and I think it is the responsibility of all of us, stakeholders, advocates, regulators, to find a balance that works for everybody. And I do feel like the more we talk and have open fora like this and regulatory processes, I think we'll continue to innovate and improve. So thank you for that last question.
And with that?
Yes,
With
thank
that
you.
final
Thank you to the
remark,
panel.
I want to, we're going to now break, but before we do, let's please thank our wonderful kickoff panel.